Welcome to Module 4, Unit 8. We're going to start off with Lesson 1. Please watch the video of a ball being thrown. And you might have noticed that it makes a shape, woo, like that, right? Otherwise known as a parabola. All right, let's go. Skip a couple pages. There it is. Look at her throwing. We're going to go right here to page 401. So, a couple things about it is we need to kind of look at the graph. All right, something to kind of think about is, if you're here throwing the ball, I know, it's an amazing, woo. Look, the ball's probably going to go up, kind of level out, and then make it back down. All right, this is not the best graph. It's okay, though. Did it start at 0, 0? No, it didn't. What did it start at? Well, it started at the height. Oh, that's not a pen. Started at the height of the person throwing it, right? Where they release the ball. So it's not down here at 0, 0. All right, we're going to start a little higher off the ground. But if you notice where it ends on the ground if no one catches it. If someone was over here catching it, then we might have a higher end spot. All right. And if you noticed, sometimes in that first video, like if you reduce the angle, it kind of went a farther distance there. But after a certain point, then it still shortens the path, right? Okay, so just different things to take into consideration. But what I do want you to notice is it represents a parabola. All right. And another word for a parabola is not linear. It's not linear. It's not exponential. It is quadratic. This unit is about quadratics or parabolas. All right. Some important things you might want to look at is maybe where you started, where a starting point, maybe an end point. And I think something else is really important, something known as a minimum or a maximum. Also, that's always at our vertex. So we might want to figure out, whoa, it got up to this high. Look at that vertex, right? All right. In the case of throwing the ball, we wouldn't put arrows on our parabola, would we? All right. So lesson summary here. You should be able to fill in linear, right? Characteristics, y equals mx plus b. The slope is our slope. It can either be a positive or a negative. The b is our y-intercept, which is very important too. All right, and then if I sketched it, it might look something like that. All right, a quadratic is U-shaped. If it opens up, then our vertex would be a minimum. If it opens down, then our vertex would be a maximum. All right, so here's an example of a parabola. Exponential decay, woo! So it rapidly wow, look at how I spelled that. I got a little carried away. Rapidly. Oh my gosh, rapidly decreases. Right? So zoom, there you go. All right. And our base, like if we have, y equals, usually we have a 2x or some kind of number here. Our base right there, in this case, would need to be, if it's decay, our base would be somewhere in between 0 and 1, right? It'd be some kind of a fraction. If it's growth, our base should be larger than 1. It's going to start off and then take off, right? And this one rapidly, let's see if I can spell this correctly, increases. And it's also not the same rate of change. It's not like a constant slope. So something to think about there. And then the last one, piecewise. Oh, piecewise is made of different functions, right? Just pieced together. So it might increase, then like flatten out. It could decrease, might go up. It could actually like have a curve in there. So that's piecewise. Okay. All right, so just something to kind of think about as we're looking at all the functions. When you get to your homework on page 408, for example, whoa, look at that. Watch out. There's a lot of scribbling. All right, watch out for where you're starting, where the maximum point is, etc. Okay? Follow that path. I'd also like to talk about, let's look at page 410. This is part of your homework, but I'd like you to figure out the slope, right? The average rate of change. Normally they give you 2 points. We haven't done this for a little bit, so I thought it'd be a good refresher. They do give us this information. So what that means is when x sub 1, when our first term, this is x sub 1. When it equals 3, what's our output? So you're going to actually plug in 3 right here. 3 times 3 is 9, plus 2 more. The output is 11. Now we have a point. All right, let's do x sub 2. So when x sub 2, we're going to input -1, plug in a -1 right here. You'd get a -3 plus 2, you should get -1. Now we have 2 points. Does this look familiar? So you have m equals the change in y's over the change in x's, and we're going to use the 2 points that we just got. All right, so that is lesson 1. Let's jump to lesson 3. We're going to look at parts of a parabola. All right, so right here, let's look at this one. Please identify some very important points on here. All right, take a look. You also have information right here. Isn't that our vertex? Right, our vertex should be at -3, -1. Let's see if it's right. -3, -1. There it is. That's our vertex. I would describe the vertex as a minimum. All right, this is kind of important. That is our y-intercept. All right, and then a couple other things would be right here and right here. What are those? Those are where our parabola crosses the x-axis. So those are our x-intercepts. All right, fill in this box down here. What is the shape of the graph? So if you just went through and say, oh, it's a U, that's good. But in math, what do we call that? We call that a parabola. Does this have symmetry? Yes. And look right here. This is important. Where is it symmetrical? I would look closer at the graph. Oh, look at this. Isn't it reflected along this line? What's the equation of that line? Isn't that x equals -3? Yeah, see, so that's more mathematical over on this side. All right, keep going. What does the function do when x is greater than -3? Oh, it starts increasing or going up, right? So the math word would be increasing. The other one would be going down before that line of symmetry. That's decreasing. In fact, let's label this our line of symmetry. Ta-da! There you go. All right. Where does it cross the y-axis? It crosses it at 0, 8. Special points. Sorry about that. See the graph for special points. All right. So it graphs it, it intersects at the, that's our y-intercept. Where does the graph cross the y-axis? Let's label that. It should be at -4, 0 and -2, 0. What's the lowest point on the graph? Oh, we talked about that already, didn't we? The lowest point would be -3, -1, and that is our vertex, otherwise known as our minimum. So lots of important points on our parabola. Okay, let's go to the next page. Take a look at this water. All right, couple things you want to notice. Look, oh, it's increasing to this maximum point, right? And then after that, oh, now it's decreasing. All right, it forms a U. We call it a parabola. All right, let's keep going on this one. This is interesting. So here's all our important line of symmetry, x-intercepts, important points. We got them all, right? Okay, there's different ways to find all this information on this graph. There's something called factored form. There's another one called standard form. And then vertex form. Now, we're going to learn all of these in this unit, but some we know more than others, all right? So we don't know how to factor yet, so don't panic. We're not factoring yet, okay? But if you're given this, look, we would be given factored form, then we can figure out what our x-intercepts are. So we can solve it. Take a look. What does y equal right here, where it intersects the x-axis? Doesn't y equal 0? So we can set x plus 1 equal to 0, and we can set x minus 3 equal to 0. See, both of those, set them equal to 0. Do you remember how to solve one-step equations? You probably do it in your head, but if you didn't, look, you do opposite operation, like that. These are really easy until I give you a fraction, and then you're like, oh no. Yep, and look, let's see if we're right. X equals 3, yep. X equals -1, yes. We did it correctly. Those are where our x-intercepts are. All right? Now the next method, standard form. Standard form, we can really take away just this part right here. If you look on our graph, look at that. If it's in standard form, it's called ax squared minus bx plus c. Anyways, the c term gives us our y-intercept. We have an a, a b, and a c. All right, so that's what that one's helpful for. The last one is called vertex form. Did you know we've been doing vertex form this whole time? Look, that's why we started with it. This is a transformation. Our vertex, isn't this our h and our k? So our vertex is just 1, -4. Look, we get that just by looking at it. Isn't that nice? Okay, now we can also solve for it. You could take the 4 to the other side and take the square root. You don't have to, all right, but you could. It kind of works nicely. All right, we're going to do that, of course, on another lesson. Okay, so what we're going to do is take a look at this catenary bridge below, and we're going to figure out where the x and y axis is. All right, let's look at the top of the 421. If I want to have two x-intercepts, where would I need to put the graph, right? If I put the x-axis right here and the y straight down the middle, look at that. Wouldn't they intersect the parabola right here? And right here? Okay, I've got two x-intercepts. All right, you try it for the next one. Where would you need to put it for 1 intercept and 0? All right, if you put it right here and here, look. Okay, that's a little off. Let me try. That's a little better. Look, there's 1 x-intercept. And then if you wanted none, well, then I would put maybe the x-intercept down here. I'm sorry, the x-axis down there. Look, does it ever intersect our x-axis? No, it does not. So sometimes we might have 0 intercepts. We might have 1. That means it's just sitting on the x-intercept. Or we might have 2. Okay? Always pay attention to your axis of symmetry. Down the middle, everything's symmetrical on both sides. All right, so what we're going to do on, well, what page is this? 422. We're going to identify each graph and the equations. I'll give you a hint on this first one. Definitely you want to look at the vertex. The vertex is at -2, -3. So I would write an equation that looks something like this. Y equals x, not -2. Remember, it's the opposite inside. All right. And quadratics are always squared. And then we move it down 3. Look, can you see how your vertex, you use it in the equation of a parabola? All right. What you're going to do is match all of these up with the equations right here on page 424. Go ahead and give it a try, and then come back to check it. All right, here are the answers. You should have gotten, sorry about that, 1, 4, which matches with C. Number 12 would be 1, -2, A. 4, 1, D. 3, -1, H. -2, 1, B. And 16, the vertex would be at 0, 4, which goes with E. And -4, 0 goes with G. How'd you do? Dun, da, da, da. All right. These are all examples of vertex form. All right. It looks a lot like our transformations that we did earlier, but it has a square on it. All right. So for the last part of the lesson, let's go to page 425. Let's take a look. It says, oh, look at that. They set out kind of the pattern for our equation, and we're going to fill it in. So if our vertex is 3, -1, that is our H, that is our K. So I'd put -1 here. I'd put a 3 here. And don't forget that the formula always has a minus in there to begin with. All right. So this would be, oh, nothing over here, plus a big nothing. I wouldn't even include that normally, +4. This one, we're doing nothing to the x, so I probably wouldn't include that either, but that's okay. And then it'd be -6, or plus a -6, whichever you prefer. I'd have 2 here, 4 here, +5, -7. Dun da da da, you did it! Congratulations!